All right, we're gonna try to get through these problems. You got three screens up here. If you can kind of follow along with me, pause if you need to, rewind, etc. I'm not going to be writing out everything. I'm going to be talking about it more than anything else. So obviously, if you're not listening to me right now, you're probably having no clue I'm saying this, but um, you want to be able to listen to understand what I'm doing here. So we got about 8 math problems we're going to work on right now. So we got this one says, what's the index of refraction if light passes from air into another medium at 33 degrees to the normal and refracts at 22 degrees? All right, so the first step is figuring out what's our formula and then thinking about our variables and then working it out. So if we go to our formula sheet, again, this is a light and optics problem. This is talking about angles, so we're going to need to use this formula that we have right here. If you list out what's known and what's known, which is your variables, we know N1 and we know theta. N1 is air, so the N is actually 1. Theta is going to be 33 degrees. And then in the object that it's going into, we know the other angle, which is 22 degrees, and we're trying to solve for the thing that we're trying to find is what is the index of refraction. So we are trying to solve for N2. All right, so that means that when we rearrange our formula, and again, I'm not going to spend tons of time going through how to do these because we've done them in class. Basically, all that I need to do is I need to get the sine of theta off of the right-hand side and move it onto the other side. And that's going to result in a fraction that's going to have n1 sine 1 over sine 2. And so we can put this into our Desmos calculator. Now, n1 is going to be 1, which we don't really have to put. And then the sine at the top, I believe, was 33. And then on the bottom, we would do the sine of the other angle, which is 22. And we get an answer, which is 1.45. That's going to be our answer. Again, index of refraction should be a value somewhere between 1 and 3 generally. So if you get that number, you've probably done everything correct with this one. Again, there's no inverse sign on this one because we're not trying to find an angle. We only do the inverse sign when we're trying to find an angle. So that is how we do number 1. Number 2, it says, what's the magnification of an image? So magnification formula is down here. So we can either use 2 heights or 2 distances. And this one says that there's an image 30 centimeters behind a lens, and the object is 10 centimeters in front of it. So we're looking at the distances in this case. So if we think about what we've got, we actually have an image distance, which is 30. And then we have an object distance, which is 10. And so in our calculator, that's just going to be negative 30 over 10, which should be negative 3. So negative means it's going to be upside down. 3 means it's going to be 3 times as big. And that's our answer of how we do that one in terms of using that formula. Third one. What's the index of refraction if the speed of light of an object is 2 times 10 to the 8th? And again, index of refraction shows up in a couple places. You're only going to use this formula if there's angles, though. There's no angles on this one, so we're going to use this formula. And again, it says we're trying to find the index of refraction, so we're trying to solve for n. C is 3 times 10 to the 8th, and it's telling us the other number is 2 times 10 to the 8th, so we could put both of those in our Desmos calculator. And if you're inputting things in your test, I would suggest just literally copying and pasting your answer right out of Desmos and putting that into your answer. That's the safest way to make sure that you have it rounded incorrectly. All right, and we get an answer of 1.5. Again, it's asking for the index of refraction, which again, I said it should be somewhere between 1 and 3, so that's probably the right answer. That means the light slowed down a little bit, and so the index of refraction goes up. That's our answer for that one. Next one, what's the frequency of a wave? Now this one's going backwards. We're not using a formula out of light and optics. We're going to be going backwards a little bit and using formula elsewhere. So we got the frequency of a wave that's got a wavelength. And the other part about this, I should have specified that it's an electromagnetic wave. Because otherwise we don't know what the speed is. So I should assume, I should write it up here. What's the frequency of an EM wave? That makes more sense. If the wavelength is 8.7 times 10 to the negative third. All right, so we got to go backwards to previous unit, and we're going to use the frequency velocity wavelength formula. So we got to use this formula. That's the formula we're going to use. Velocity, we know velocity is going to be this number down here, 3 times 10 to the 8th, because that's how fast light travels. And then we've got a wavelength. So we got a V and we've got a wavelength, which means I'm solving for F. So if I'm solving for F, I need to get F by itself. F is being multiplied by the wavelength. So we need to move the wavelength to the other side. We would do that by dividing it out. So I need to do velocity divided by wavelength. And if I do velocity divided by wavelength, I've already got velocity at the top of this fraction, so I'm not going to get rid of it because it's already there, because it's still the velocity of light. And then our wavelength is 2 times, excuse me, our velocity, excuse me, wavelength, 8.7 times 10 to the negative third. Put that in the calculator. And I'm going to get this answer here. Again, safest thing to do in terms of inputting it in your calculator, copy it, paste it. Should be the right answer when you do it that way. All right. So again, we got a big number that we have right here. So that's going to be a really, really high frequency because we have a really, really small wavelength. Remember, those two things go in opposite directions. So that kind of makes sense. When you have a number that's 10 to the negative third, that's a really small number. So it's a really small wavelength, which is going to result in a really high frequency when we have that. All right. Next question. How long would it take light to travel a certain distance? And again, this is about a time formula. It's not a distance. So we've got to be careful when you're reading that. How long would it take? Usually it's talking about time to travel a certain distance. And again, we're talking about light. So we got a distance. We know the speed of light, and we're looking for the amount of time. That's going to take us all the way back to first unit and to use this formula up here. So velocity is distance over time. If we rearrange this, if we put it into a formula, time and velocity can switch places with one another. Distance is always going to be at the top. So if we're doing time, it's going to be distance divided by velocity in this case. So I'm going to take this number right here. I wonder if I can, I don't know if I can copy and paste that. Probably shouldn't. All right. So again, it's a division problem. My distance, again, is going to go on top. My distance is 7.87 times 10 to the 12th. And the speed of light, again, 3.0, which you don't have to put the time 0.0 if you don't need to, times 10 to the 8th. And I get 26,233. Again, if you want to copy and paste that whole thing to stick it into your answer, that should be correct. Now, again, this is going to be in seconds because the reason it's going to be in seconds is because the speed of light is in meters per second. Right? So that's going to be the unit that we have for that. And that gives us our answer. Getting close to the end here. All right, we're looking for an angle of refraction this time. So the angle of refraction, that means we're going to be using this formula. Remember, if we're using angle of refraction, we're going to be looking for an inverse sign to get the answer on this one if we've done it enough times. So we've got to move, we want to have these two things on top of the fraction. And if we get to our formula, the N for air is 1, right? And the incoming angle is 25. So that's going to be on the top of our fraction. Oops, let's delete that. So I don't really have to put the 1, but I'm put there, make sure we know what we're doing. And it's going to be the sine of 25, right? So that's the top of our fraction. We know n on the other side, so we got to divide it out, and so it ends up on the bottom of the fraction over here, and it tells us this is 2.1. And that would leave us with sine of theta on the right-hand side, but we're trying to find theta and not the sine of theta. Those are two different things. So we need to get rid of the sine, and the way we get rid of sine is to multiply by the inverse sine. So we're going to put the inverse sign on the front of that. We don't really have to close the parentheses up in the back. Make sure you're using scientific calculator and you're on degrees, and we get a number that's 11.6. That seems like a reasonable angle because if we started with 25-degree angle, if our light slows down, our angle should get smaller as it bends towards there. So again, we could copy, paste that, stick it into your answer. That should be our correct answer for that one. All right, last two. This one says, what's the focal length? So focal length, we're going to be using this equation. F is our focal length. You will see the F is in two different places, but these two equations are basically the same thing. So my focal length is right here. F is -1. Right. And it tells us the other things that we have is it asks us the object is 50 centimeters to the left, so that's the DO, and the image is 30 centimeters to the right, and that's our DI. So it gives us the DO, it gives us the DI, and then we can just pop these into our calculator. Now this one's a little bit tricky because remember we've got an inverse over here, so there's a little, I won't say special step that we have to do at the end, but we're going to have 1 over the DO, which was 50. And we're going to add that to 1 over the DI, which was 30. Right, so this is going to give us our answer right here. So this is not my answer. This is 1 over the answer. So here's our easiest thing to do with this. As I said in class, I could flip 1 over F upside down and make it F over 1, but I've got to do the same thing to this. It's basically like if you hit the little button here, it shows you what the fraction is. So 1 over F is equal to 4 over 75, and so I need to flip this over so it's 75 over 4. Now, if you do this, you could just type in 75 over 4 and go, okay, I've just flipped it over. So here's one way. I could do 75 divided by 4, and I get 18.75. That's fine. Or if you've got this number right here, another way you can do it is just simply say, all right, I'm going to put 1 over that number, and you can hit the answer button, and it's also going to give you 18.75. So a couple of different ways you can use your Desmos calculator to be able to do that. Again, does that seem like a reasonable answer? Well, usually the focal length is somewhere in between the distances of the other two, and or close to it or inside of it. It's usually smaller, but it's in the same kind of number here because we got numbers of 50 and 30, and we got 18.75. Like again, that number is way too small to be a right answer, so that should be your point that you have one more step to do. All right, last one. It says how fast does light travel through a material that has a refractive index of 2.8. All right, so it gives us a refractive index of 2.8, and it's asking about light traveling through something. So we're going to go back to use this first formula, except in this case, we're not solving for n. It says how fast does light travel, all right? And so how fast light travels is solving for the v. Again, we know c is always 3, and we know n, which is 2.8. All right, again, when we have a problem like this, if you turned it into a triangle or you rearranged your formula, n and v can switch places. All right, the top of the fraction is always going to be the top of the fraction if these two variables need to be changing place. If you made a triangle out of this, c would be at the top, which means that c is always going to be at the top. So velocity then is going to be c over n. And this is also another one where if you did it upside down, or you did it backwards, your answer should tell you if something's wrong, because we're talking about how fast does something travel. And we should get a pretty big number right here. All right, so c is going to be at the top again, 3.0 times 10 to the 8th. And I'm going to divide that by the refractive index, which is 2.8. And so I'm going to get this number right here, 107,142,857. Again, copy paste that directly into your answer box if you're asked for an input, and that should be the right answer. Again, does that seem like the right answer? How fast does light travel? Should be a big number, right? If you got this answer upside down, like if you flipped your fraction over for some reason, you would end up getting a number kind of like this. And hopefully you'd say to the -9th, that's a really small number. And so I've done something wrong. All right? Light should not be traveling at 10 to the -9th. That's super slow. That's a tiny number. So we would want something that's going to be big, indication that you probably put something in wrong. So use your answers to just kind of common sense double check if you're doing things correctly. All right, I'm going to stop there, do the rest of it on another video just to break it up.